Hi, my name's Andrew. I'm going to work through this problem here. How many grams of ammonia, which is NH3, will form when 24 grams of hydrogen gas are completely reacted with nitrogen gas? So this type of problem is asking you about how much of a product can be formed based on the amount of its reactants. Now it gives you your amount of hydrogen gas in grams, and then the question is asking you for how many grams of the product you get. Now, getting from grams to grams seems straightforward, but the reality here is that we're going to have to convert from grams to moles in order to make sure that they have the correct stoichiometric relationships. So the very first thing that we're going to need to do is we're going to need to balance out our equation here. And so I'm just going to kind of walk through that process here. I like to keep tallies of how many of each element there are and go from there. So H, there's 2 here, and there's 2 here, and there's 1 here. H, there's 3 here. So more hydrogen on the product side than the reactant side. So I probably have to boost the reactant amount of hydrogen. That puts me at 4. But there's only 1 nitrogen on the product side, so I'm going to need at least 2 of these to match with the reactants as is. So 2 nitrogens, 3, 4, 5, 6 hydrogens. So nitrogens are balanced right now. They both have 2, but hydrogens are not. So I'm going to actually have to go for 3 here, hydrogens. 4, 5, 6. Now my hydrogens are matched at 6, and we're good to go. We've got a balanced equation. So then we've got to convert our grams to moles. So 24 grams of hydrogen, that's H2. How many moles of hydrogen is that? So here we're going to have to know the grams per mole of H2. And so H2 is 2 hydrogens. The hydrogens over here on the left side of the periodic table, 1.01 per hydrogen. So that means that its molar mass is going to be 2.02 grams per 1 mole of H2. And we do the calculation there, and we're going to get somewhere close to 12. I could pull out the calculator, but we'll do some rough work here. So 12 moles. Now 12 moles of what? It's 12 moles of H2. So now we got to think about the stoichiometric relationship between H2 and our product. So 12 moles H2. Well, for every 3 H2, there's 2 NH3. So for every 3 H2, there's 2 NH3. So that means that in the end, we're going to have 8 moles of NH3. Let me work that out. Moles H2 cancel out. We're left with moles NH3. So now we got from amount of moles to amount of moles. Now notice I did not care about how much nitrogen there was. That's because the question said completely reacted with nitrogen gas, so we can assume that it's in excess. So then 8 moles NH3. The question is how much, or what's the molar mass, the grams per mole of NH3. In this case, we're going to want grams per mole set up like that because we want moles to cancel out. Now, going back to our periodic table here, nitrogen is 14.01. So 1 nitrogen, 3 hydrogens, going to put us at 17.04 grams. Let me see if I can get that clearer. 17.04 grams per mole of NH3. So 8 times that, you plug that into your calculator, and then you are good to go. That's your grams of NH3 that can be produced from the starting amount of hydrogen gas, H2. Hope that's helpful for you all. Have a good one.